Welcome to my first episode, and today we're going to be jumping into deriving and differentiations. If you're new to this channel, please follow. My name is Mark. I'm Maths with Mark, and I make math content a little bit easier to understand as we walk through some difficult concepts as well as some exam style questions. So today we're going to be jumping into differentiation, what it is, and the key kind of concepts that you'll learn, especially if you're in year 11 or 12 in Australia doing your HSC. We'll learn the kind of topics that you will face, and we will go through a few examples as well. So, differentiation, what we're going to be going through today, we have four different topics that we're going through. We'll start off with the basic one. We'll do the power rule, so deriving functions just by using the power rule. We'll then look at chain rule, so deriving functions just by the chain rule, and then product rule and quotient rule, which are a little bit difficult. But once you've kind of mastered the first two, those become quite simple. So let's jump straight into it. Let's look at some topics. We'll go together through this. So we've got ourselves the power rule. What is it and how can we derive functions for it? So power rule is given as a formula like this. So we've got d dx, which just means the derivative of a function of, let's say, x to the n, x to some power, and we're asked to derive it. So in this case, when deriving a power function, we mainly just look at those powers. We bring the power down to the front, we multiply it by the function, and then we subtract the power that the function was given to by 1. So that is the original formula. That is probably going to be your reference sheet, your cheat sheet, whatever you want to call it. That is what you'll be referring to when dealing with functions and polynomials that are just power related. So let's keep going in. So if we were to obviously look at a real example here, for example, let's do the function f of x equals 3. Let's just do a nice one. X cubed. Right, how will we derive this? So let's go and do f dash of x, which just means the first derivative. And then we're jumping into now following this kind of formula that we did before. So we grab that power being the cubed, and we bring it to the front. So here we'll have 3x, and now we're going to follow this part up here, n minus 1. So 3 minus 1, and that's going to be 2. And that is your complete full derivative there of power rule. So again, power rule is relatively easy. It's not the most difficult concept to learn. Obviously, as we dive into a little harder ones, you'll start to see as why this one's relatively a bit easier than the others. But this is really fundamental. We need to make sure we are mastering this part first, so then we can make the other four sections that we learn next relatively easy. So let's just jump into that. So another example that we can do. So let's do another example. We'll bump it up now. We will add a constant in front of the function, and we'll add a few extra variables as well. So for example, a nice quadratic function, let's do 2x squared plus 3x. So here we have a non-monic quadratic, and we're asked to derive this. Again, same thing here. We're going to be following this formula above, this product rule, power rule formula, and we're going to be using this now to help us apply some differentials. So again, same thing. F dash of x is equal, and now because we have multiple variables, so multiple x values in this kind of formula, we just want to think about this as doing these separately. So you can apply this rule up here, but now we're going to be doing it separately to each of them, and then just at the end, add them together to create the new function. That's what I can't tell most of my students, makes it a little bit easier to understand. So we have the derivative of 2x squared, same thing now. When we follow this kind of formula, we have the 2 in front of the x squared. So what I like to say is you can separate the 2 right now and write it like this. So 2 times x squared. And we can derive the x squared now part separately. So same thing, you bring down the power and then you do 2 minus 1. So the power minus 1, which is just going to be to the power of 1. So we leave it like that. And then we can think about it as like 2 times 2x, which is the same as 4x. So the first derivative is going to be 4x because we basically want to think about it like this. The power of 2 times whatever's in front of the coefficient, and then we just subtract the power. And that's how it is. So let's quickly just rub this out with some space. We now move on to the 3x parts. We go plus the derivative of 3x. Same thing. Think about it as 3x to the power of 1. We bring that power down to 3 times 1. So 3 times 1x to the 1 minus 1. So in this case, we have 3 times x to the 0. And if you know your index laws, anything to the power of 0 is just 1. So we go ahead and we just have our answer as 3. So the final part would be 4x plus 3. And that is the rule of thumb when dealing with any kind of singular degree coefficient. So x, y, m, q, anything to the power of 1. If you derive it, that's going to disappear. And that's how you want to kind of understand it from the start. So that is your final answer there for the derivative of 2x squared plus 3x. You get yourself 4x plus 3. And that is basically power rule and everything you kind of need to know about it. So yeah, if you guys did enjoy that part of this episode, please like, please follow. At the same time, also feel free to comment down below what you want to learn next, what you want to see next, because again, I'm just doing these videos as kind of content, learning. If you don't follow my TikTok, Maths with Mark, please follow it. That's where I post kind of short multiple choice answers, short kind of recaps on questions. But again, if you're here for the long run, here for learning, these videos are more entitled for you. So let's jump now into the next rule that we learn. The next rule is relatively a little bit more difficult, and it's chain rule. Now, your school might do it differently. You guys might learn product rule and quotient rule first, and then jump into chain rule. I like to teach this when my students go from power rule, chain rule, and then product and quotient rule. Because product and quotient rule are very similar, but they're just a little more difficult. And I feel like if you can get chain rule very confidently, you can get the other two very, very easily. So chain rule is basically when you have a function inside another function. So when deriving, we have this d dx, but this time now we have an f function, and inside that is a g of x function. And what that looks like in exams and relatively all the questions you'll be able to tell the chain rule is when you're dealing with a function that looks like this. X squared plus 2 or something inside like a cubic, a polynomial, a linear, x, whatever, to the power of 2. As you can see here, well, let's do actually a power of 3. I think a bit more interesting. As you can see here, you have on the outside, the brackets, you have a cubic function. But on the inside of this bracket, you have a parabola. So that's what it means by a function inside a function. You've got two separate functions inside of each other. And that's why deriving these become a little more difficult because you can't just do the power rule. So let's have a look at how you want to derive these kind of things. So let me just quickly move this down a little bit. We'll do that one in a second. Let's have a quick look here at what the derivative looks like as a formula. It basically is given like this. So the function derived a function inside of it. So we've got ourselves f of g of x. So the derivative of the function on the outside, which is just going to be a power rule, multiplied by the derivative on the inside, which is also just going to be a power rule. So basically, this is that looks like a plus times. Basically, this is just like two separate power rules, but you just make sure you multiply them together to kind of get that. So what that actually means, looking at that kind of formula, we'll look at this example and kind of get an idea. So this example here, we've got ourselves x squared plus 2, brackets also the power of 3. So we treat the brackets as like the f function, so let's derive that first. So again, it's like a power rule kind of question, so it's going to be 3 x squared plus 2 to the power of 3 minus 1, which is going to be 2. That's the first part, all done, very simple. Like if you want to think about it in the brackets, just ignore it for now and just do the power rule for this part. Now we want to times by the derivative of the inside. So we can see we've got x squared plus 2. We know 2 has no x on it, so we're not deriving that. That's just a constant that just turns into 0. But we've got that x squared where we can now use the power rule again. And we know that x squared, the derivative, is just going to be 2x to the 1. So we're just multiplying here by 2x. And now, once we've done this part, we can go ahead now and just times them all together. We know that the brackets we can't do anything about, but we have two numbers on the outside multiplying together. So we can go 3 times 2x, which becomes 6x, bracket x squared plus 2, all the power of 2. And that there is your derivative, and that is applying chain rule. So again, chain rule is very simple. You're just kind of giving two functions their own kind of single formula, and you're just deriving them with the power rule. Alrighty, let's do one more real quickly here. Another one that you can give in an exam that might look a little bit more difficult is another chain rule question, is the function of a square root of x cubed plus 2x plus 1. Let's do that. This is again really nice. This is challenging a few more of your power rule concepts. We didn't really dive into negative indices, etc., in the first section. Obviously, after you've done a bit of power rule class, or you're kind of looking into it, you'll understand what negative indices and how they apply. But for here, we use our index laws and we instantly know that the square root of something can be written as a fraction indice. So we can write this as x cubed plus 2x plus 1, or the power of a half. And now we have ourselves two functions. Before, you can kind of see it a bit more clearer. You've got yourselves a square root, so a function of that, and then you've got yourself a polynomial inside, which is a cubic. So you've got two functions here. So the same thing, we want to derive the outside first, and then to multiply by the derivative on the inside. So let's go ahead, bring that half down. Uh, Everything in the middle stays the same, so everything inside the brackets, plus 1, all to the power of negative a half, because 1 half minus 1 is negative a half. Sweet. Now we want to multiply it by the derivatives on the inside. So we go ahead now and look at the inside here and go, cool. We bring the power down from the cubic. We get ourselves 3x squared. Feel free to put this in brackets if you want to separate it. That's fine. 3x squared. We know the 1's not going to be a derivative because it doesn't have an x. But we can now derive the 2x, which we bring the power of 1 down. So 2 times x to the 0, which is just going to be plus 2. And that there is your derivative, but we're not quite done there yet. Usually in exams, they're going to want you to simplify it. They're going to make it look nice. So let's go ahead and do that. So negative indices, what happens? How can we change these to a positive? Well, to change it to a positive, you write that as the reciprocal. So what it looks like is going to be 1 half multiplied by 1 over the square root of x cubed plus 2x plus 1. Feel free to write that as 1 over the x cubed plus 2x plus 1 brackets to the power of a half. That's fine. I'm just kind of skipping that step and writing it as a square root because that's the more simplified answer. And now we have it multiplied by 3x squared plus 2. Awesome. Now you've got a few things multiplied together. We know how fractions work. That 2 is going to get multiplied by the denominator. The 1's going to get multiplied by the top. And the 3x squared plus 2x is going to get put on the top. So let's go ahead and now write this as a simplified version. So therefore, the derivative of the function is given as 3x squared plus 2x. Feel free to keep the brackets there or to take them away if you want. All over 2 square root x cubed plus 2x plus 1. And that there is your final answer. So again, we can see that chain rule is a little bit more complicated when jumping into more complicated functions. But again, you master the power rule, you can master chain rule very easily. It just requires a little bit more of index laws knowledge and you just being a bit more confident with simplifying a few things. And again, just deriving functions separately. But again, do some examples of these, work some questions out, and you'll start to see these will come together very, very, very quickly. Alrighty. So that is the first two rules. We now jump into the final two. These ones will get a little bit more difficult, but again, if we are confident with our knowledge, these will be fine once we've learned them. So let's jump into this. So we'll start off with the nicer one of the two. We'll jump into product rule. Product rule. So it kind of says it in the name, product rule. What do you reckon I'm going to say? Well, if you knew chain rule was a function inside a function, we can assume that product rule is going to be where we have two functions being multiplied by each other. That's why it's called product, because you have two products or two functions being the product of each other. So what that looks like in obviously the first kind of lessons that you start to learn this concept, you'll be dealing with just basic kind of functions like polynomials being times by linears and etc., etc. But as we jump into a little more later on in exam style questions, they will start to throw functions that look like this, like exponentials being multiplied by, parabolas, or for example, trig stuff being multiplied by, um, again, that kind of stuff. That is where obviously we want to jump into a little bit of knowledge. But for now, we're going to look at some more basic kind of functions. So let's just jump into that. First one we're going to do today is we're going to look at x squared, x plus 3. That is a function. We can see here we've got ourselves a parabola, and we can see ourselves that we've got ourselves here a linear function. So two separate functions multiplied by each other, and we can do it right. Now, I'm only doing this one as an example to show the basic concepts of prog rule. We'll probably do the next one a different function because what you might be looking at the screen now going, kind of not just expand this. You can expand this and then it just becomes a basic power rule question. But for now, we want to kind of get the understanding of prog rule. Either one is correct, but again, like we like to do, we like to have efficiency in exams. So yes, you could expand this and do power rule. But for now, we're just going to learn how prog rule works, what it looks like, how to deal with it. So the derivative of prog rule looks like this. You got yourself, that shouldn't be there. We got ourselves here a function of f and g. Right, function g multiplied by function f. And how that looks is the derivative of function f multiplied by the normal g function plus the normal f function multiplied by the derivative g function. Again, seeing f's and g's, the root and stuff, some schools and some classes do uv plus uv, but like uv dash plus u dash v. Right, same thing, same concept. How you want to learn it, how you feel it is totally up to you. So what we can do is here, let's use the u's and v's, because I know a lot of schools in New South Wales do that. Let's just do that one. We got ourselves here u being x squared, and we've got ourselves x plus 30 being v. What I like to do is I like to set up this kind of cross kind of rectangle kind of structure. V equals x plus 3. And then you've got yourself u dash being the derivative, so power rule being 2x, and v dash being the derivative of x plus 3, just being 1, because you bring the power down, 1 times x to 0 is just 1. Awesome. You've now got this, and because now we're basically linking up these kind of ones, we'll go back up here. We've got u times v dash plus u dash times v. So basically, what we can do is here, you can kind of times these together, and add them. So what we can do is, for our function, we're going to have x squared times 1, and then we're going to have plus 2x times x plus 3. And that there is going to be your derivative of this function. So let's have a quick look. X squared times 1, well, that's just going to be x squared plus 2x bracket 3x, x plus 3. Let's go ahead and expand that. We get ourselves 2x squared plus 6x. Awesome. Let's go ahead. We know the like terms are here. We've got the x squares. Let's go ahead and add them. So we get ourselves here 3x squared plus 6x. And also, that's your final answer. You can factorize this if you want, but for now, I'm only worrying about getting your understanding of the concepts down. So yeah, that is prog rule, and that is how you want to do it step by step. In a few other videos, I'll do an episode on this where it's just prog rule on its own, same as quotient rule, where we dive into now more advanced complex functions. For example, exponentials, trigonometric functions, hyperbolas, negative indices, etc., and how we can deal with those when dealing with prog rule. But for now, I just want you guys to be able to follow along, have this written down, or be able to look at some quick examples in your book from your homework or your test papers that you're seeing, and be able to just understand how prog rule is worked. But later on, we'll apply this to some exam style questions. Alrighty. We are now down to the last one. If you guys are still watching, I am really grateful and really happy that you are. So please like, please subscribe. But now we're jumping into the final one, which a lot of students find difficult because it's just, again, harder to see in an exam, looks a bit more ugly, a bit more complicated, and it is given as the quotient rule. Quotient rule, again, don't worry about my spelling or how I write. I'm a math student, not an English student. So let's look into this. Quotient rule, we knew a product rule was just the product of two functions, so we can go ahead and assume the quotient rule is just the two functions being divided by each other. Hence why quotient. Quotient means divide, if you didn't know that. So let's have a look. So we're given a function of f over g. Same thing, you could do the function of u over v. U and v being two separate functions, and this is where now it gets a little more complicated. So when asked to derive these, what it looks like on the formula. We'll go ahead and use these u's and v's again. We're given, for example, u dash times v minus u times v dash all over v squared. Now, this is where it gets a little more difficult. The v is always going to be the denominator. You cannot put v as a numerator. So in this case, v is always going to be the denominator and u is always going to be the numerator. And this is the only way you can write and express the derivative formula. So where product rule you had in product rule you had u dash v plus v dash u. You could write that around. You could do v dash u plus u dash v, right? You can swap it around and you'll still get the same answer because with scalar multiplication and addition kind of laws, when you add two different functions being multiplied by each other, you will always get the same answer. However, we're now dealing with the subtraction rules and subtraction laws. When you are multiplying two different functions and you're subtracting, the way you format it will get different results. So we must make sure that we follow this formula here. Again, will be on your reference sheet in your exam, so you can always follow it there. For now, don't worry about memorizing this. Just be able to use this formula to get the answer. So let's jump in. Same kind of thing. We'll do another example. Let's have a look. So we've got ourselves here. Let's do the function of x squared over x to the power of 4 plus 2x. Right. You can see here we've got a parabola on top, a function on top, and we've got ourselves here a polynomial on the bottom, which is, again, two functions being divided by each other. How can we express this? How can we write this? Well, let's go ahead and straight away give each of them a value. So u, we know v is always going to be the numerator. And let's go do the same thing we did for product rule. Let's create this little kind of key. So you got u equal to x squared, v equal to x to the power of 4 plus 2x. And then same thing. We got ourselves u dash, which is equal to 2x, and v dash, which is equal to 4x cubed plus 2, excuse me, plus 2. Right, so there are your four different ones, which you will do cross multiplication soon. But we also have to remember we have to add the one final step, which is the v squared, which is just going to be x to the power of 4 plus 2x to the power of 2. All right, awesome. You've got all the parts now. Let's add a new page. All the parts, we now want to follow this formula. So u dash times v. So we'll go ahead and go u dash times v, which is going to be given as 2x bracket x to the 4 plus 2x. Right, and then we've got ourselves minus u times v dash. So we've got u times v dash. We're going to go minus x squared times 4x cubed plus 2. Ooh, let's move that back into the middle. Right, brilliant. And now we know this is going to be all over v squared, which we have v squared right here, which is going to be x to the 4 plus 2x squared. Awesome. We now, again, you could be asking, can I expand these and simplify this? Absolutely, you can. In the exam, leaving it in this format is still going to be given as correct. It's still a correct derivative of the function, and this will get you enough marks if you were just deriving this function on its own. Now, if you had an exam that was requiring you to find a tangent or some value, you can simplify this to get a more kind of simplified fraction, which might help you find an exact value a little bit easier. But same thing, you have a calculator for a reason. You can plug in the values for x into this format. Alrighty, that is deriving with quotient rule, deriving with product rule, chain rule, and power rule. They were just the fundamentals. We'll do another episode soon where we're dealing with exam style questions. But if you guys did enjoy, please like, subscribe, comment down below what you guys want to work on, any other questions, any other topics, because again, I want to start making more content. Obviously start bringing over my TikTok followers to you guys, and you guys go to TikTok and we can work together and we can make this hopefully a very friendly channel where we make a lot of good content. So thank you guys, really appreciate it. Yeah, like and subscribe.